A feedwater tank is an essential component of any steam boiler installation. It is a piece of equipment where makeup water and condensates are mixed, heated, treated, and stored before they are fed into a steam boiler. But what exactly are its main functions and components? We'll go into that in this Steam Nugget. A feedwater tank is also known as a deaerator. It has three main functions. The first is to mix condensate with makeup water. When steam releases its latent energy, it turns into condensate. In other words, it goes from a vapor state into a liquid state. That condensate is full of sensible energy. To save energy and water, it is important to collect the condensate and return it to the feed tank. But because the condensate can almost never be fully recouped, it has to be complemented with makeup water that comes directly from the treatment plant. The second function of a feedwater tank is to act as a buffer. Since boiler feedwater pumps would suffer from pressure and flow fluctuations, the feedwater tank acts as a buffer tank by disconnecting pumps from the makeup water network and condensate network. The third function of a feedwater tank is to prepare the water and make it meet the required chemical-physical parameters. To avoid corrosion and other potential damage, boiler feedwater must adhere to specific chemico-physical parameters. These parameters, or norms, are defined by the boiler industry, and they address several different aspects such as pH and dealing with dissolved gases. The pH value of the water, its level of acidity, must be restored to proper levels to avoid acidic corrosion. This is achieved by chemical dosing. The makeup water and/or the condensate that is returned to the feed tank can contain dissolved gases. These must be removed. The removal of dissolved gases is called degassing. It can be achieved thermically, by increasing the water temperature within the tank by way of steam injection, or it can be achieved chemically by the way of chemical dosing. The English chemist William Henry formulated a gas law that is relevant here. It states that the amount of dissolved gas in a liquid is directly proportional to its partial pressure above the liquid. This graph lays out the relationship between water temperature and oxygen solubility. It clearly shows that the higher the temperature of the water, the less dissolved gases will be found. Any non-condensable gases are removed using the vent located at the top of the tank. Heating the water in the feedwater tank is an important process for dissolved gases elimination, but it also reduces the risk of thermal shock where boiler design is concerned and improves the stability of the boiler water level. Exactly how high can we get the temperature to be in our feedwater tank? Well, that depends on the type of tank. Because they are atmospheric, feedwater tanks cannot reach 100 degrees Celsius, 212 degrees Fahrenheit, without vaporizing and wasting energy and water. On the other hand, deaerators or degassers are slightly pressurized and allow water to exceed 100 degrees Celsius without vaporizing. At that temperature, there will theoretically be no more dissolved gases left in the feedwater. To ensure its proper working, a feedwater tank comes equipped with two different regulation systems. The first is water level regulation. There must always be enough water in the feedwater tank or in the deaerator to prevent the feedwater pump or pumps from running dry and guarantee continuous steam production. At the same time, there should not be too much water to prevent overflow. The second regulation system takes care of the temperature. To remove dissolved gases by increasing the water temperature, steam is injected into the feedwater tank. It is important to keep the temperature as high as possible, but not too high, because this would cause energy losses. Remember, the feedwater tank is an essential part of a steam boiler installation. It helps ensure efficient, safe, and reliable operation by storing, preheating, and treating the feedwater before it enters the boiler.